This is Mr. Campbell. This is topic 1A, lesson 4, domain, range, intercepts, increasing, decreasing, constant intervals, positive and negative intervals, and rate of change. So, car starts a journey with a full tank of gas. The equation is y equals 15 minus 0.05x relates to the number of gallons of gas left in the tank and the number of miles that has been traveled. What are the x and y intercepts of the graph, and what do they represent? Okay, there's the x-intercept right there, which is, when you hear intercepts in math, that means ordered pair, which means position. And the y-intercept is, of course, right here, which would be 0, 16. Intercepts, you always write them with ordered pairs in math because they mean position. The x-intercept represents the car travels 320 miles before gas tank is empty. The y-intercept represents the full tank of gas. The domain, of course, remembers all the x values, so it's all possible, spell much, possible inputs. Those are the x values. The range are all possible outputs. The y values. The x-intercept is the value when y is 0. On the x-axis. On the x-axis. The y-intercept is the value when x equals 0 on the y-axis. Interval where a function is increasing, it's going up, y goes up from left to right. From left to right. Interval where a function is decreasing, y goes down from left to right. And function interval where function is constant, y stays the same from left to right. Interval where function is positive, it's all the values that are above the x-axis. Where y is greater than 0. Interval where function is negative is below the x-axis. And it's where y is less than 0. Okay? So, again, if we graph this in with your calculator, so if I put this in our graphing calculator, turn it on, of course. So we go to y equals, clear that out, and put in opposite to x minus 3. I like to always use zoom 6 and hit graph, and there's your line, okay? And if you remember slope intercept, y equals mx plus b, you know the y-intercept's at negative 3, and the slope would be down to right 1. Down to right 1. So I can draw my line. I'm going to get my ruler here. I'm going to pause this because I need a ruler. Draw my line. Okay? All right, so the x-intercept is at, and if you wanted to find the x-intercept on your graphing calculator, it's where y equals 0. So what you do is, you get this up a little bit where you can see all the steps. Most of them, at least I think. So to find where the x-intercept is, what you can do is you go to math. Go to trace and hit the blue key. First hit the blue key, blue trace, and you see where it says 0? Hit 0, number 2, and the 0 is where the graph intersects the x-axis. So what we need to do is we need to get to the left of that 0, which is going to be above the x-axis. Notice my x values are negative, but my y values are positive. So I hit enter, and you should see a little triangle come up. Then I right arrow where my little mouse is below it, hit enter, and hit it again, I get negative 1.5. So my x-intercept is negative 1.5. Whoops, sorry. Negative 1.5, comma 0. I'll do that again with you and show you how to do it. So go back to your graph. So hit the blue key, the second key, and trace, and hit number 2. Now it's going to ask you, it's when it gets that thing to the left of the graph. So just hit left, get it left of it, which is going to be above the x-axis, and enter. And that triangle's to the left of it. Then right arrow down so you're below the x-axis or to the right of it, hit enter, and then hit enter again. You got it, negative. So you're going to hit enter 3 times, okay? Now to find the y-intercept, that's where x is 0. That's easy. You can just go to your table. So hit the second key, table, and you see where x is 0, it is negative 3. And we should already know that from the equation, right? So the y-intercept is 0, negative 3. Okay? The domain of any move this down here a little bit. The domain of any line is all real numbers, and so is the range. Okay, so that's negative infinity to infinity. Now it asks where it's increasing. Well, it's really not, it's never increasing, because as I go from left to right, the y values are getting smaller. So this one here, there's no increasing, but it is decreasing for the whole thing. So that's increasing for the whole line. And constant, it doesn't have anything. It doesn't have a horizontal line. It's not constant anywhere. So it's never increasing from left to right, it's going down. But from left to right, it is decreasing. And there's not a constant would be where it would level off, but it doesn't. Now it asks for where it is positive. Okay, so where it is positive is where it is above the x-axis. Okay, so I'm going to get a couple colored pens here. And notice that it is positive here. And it is negative here. So and you want to write the interval where it is positive, which is in orange. So that interval where it's positive, and we're talking about the x now, and remember negative infinity's here, would be negative infinity to 3/2, or negative infinity to negative 1.5. And again, you don't use brackets because at that point right there, it's neither increasing or decreasing. And then it's negative from negative 1.5 or 3/2, same thing, from here over to positive infinity. Okay? And they want to find the average rate of change from x equals 2 to 6. Okay? So in your calculator, let's find out what the value is for x equals 2. So our x at 2 is 2, negative 7. So for x equals 2, my ordered pair is 2, negative 7. For x is 6, I look at my table, and it is 6, negative 15 is my ordered pair. Now we want to find the rate of change. The rate of change is slopes. How many remember the slope equation? Y sub 2 minus y sub 1 over x sub 2 over x sub 1. Difference of y's over difference of x's. So I'm going to take negative 15 minus a negative 7 over 6 minus 2. So negative 15, negative of a negative means plus. So I get negative 8 over 4, which would be negative 2. So my average rate of change is negative 2. It's a constant. Okay? And to be honest with you, you should know that. What's your slope? Negative 2. Okay? All right, let's do the next one here. Y equals x squared minus 4. So I'm going to plug it into my graphing calculator. Okay? My graphing calculator. So y, I'm going to clear that out. So I'm going to hit x, which is below mode, correct? X is below mode. X squared minus 4, and then another x, and I like to hit zoom standard again. Number 6. Okay? It's a quadratic, isn't it? Okay, so the x-intercepts are where y is 0, and it looks like to me, I'm going to go to my table, it looks like it, 0, 0. So my x and y intercept, at least one of them, the x-intercept is 0, 0, right there. I've got another one, and then my y-intercept is 0, 0, but I only have one y-intercept because it intersects right there. Now let's find this other x-intercept. And remember, if you go to your table, you'll see where y is 0 is your other x-intercept. So my other x-intercept, remember, is where y is 0, 0, 0, and 0, 4. Okay, so we get 4, 0 is our other x-intercept. Okay? All right? So let's graph this thing. So we've got 0, 0, 4, 0, and then 1, negative 3. I'm just getting these points right off the table right here. 1, negative 3, 2, negative 4. And notice here, I got 1, negative 3, 2, and then I got another 3, negative 3, so I know that's the lowest point right there. And then I draw my graph. Okay? So it looks like this. Okay? All right, my domain is left to right, so it's going to be all real numbers, okay? I can put whatever I want in for x. My range, if you remember, is floor to ceiling. Floor to ceiling, okay? So my floor is negative 4, brackets because it is a point, and then the ceiling would be positive infinity, non-included, okay? All right, now, increasing. It's increasing from here going this way. So what is x for that? So it's increasing from 2 to positive infinity, going that way, 2 to positive infinity, and it's decreasing from negative infinity to 2. So it's going here to 2, then it's going back up. And there's no constant here, correct? Okay? Now, where is the graph positive? Well, the graph is positive here and here. So my interval for where it's positive, now remember, we're talking about the x values, okay? Which would be, over here would be left to right, negative infinity to 0. Ooh, it's one of my x-intercepts, isn't it? Correct? And the other one would be from 4 to positive infinity. So it ends up using your x-intercepts. Now, it's negative. Let me get another pen. It's negative from this right here. Okay? So that interval is from 0, non-included, to 4. Now, my y values are negative. My x values are from here to here. Okay? So from 0 to 4. Now, let's find our average rate of change for x equals 2. So at x equals 2, we can go back in here and get our ordered pair. So 2 was what, negative 4? So 2, negative 4. And the other one they want is 6. So if you look at your calculator, your ordered pairs are 6. That's 612. So we're going to find our average rate of change, correct? So that's going to be difference of y's over difference of x's. So 12 minus would be 16 over 4, which is equal to 4. So our average rate of change is 4. Okay? All right, let's go to the next one. Okay, this is a horizontal line and y equals 2. Agreed? So y equals 2. There we go. It's right here, horizontal line. Okay, it didn't have an x-intercept. The y-intercept would be 0, 2. The domain's all real numbers, isn't it? But the range is just 2, isn't it? Just 2. No matter what I put in for x, I'm going to get 2 for y. It's neither increasing or decreasing here. It's a constant, isn't it? And it's a constant throughout the whole thing. So that's negative infinity to infinity. It's positive for the whole thing. It's never going to go below the x-axis. So that's also negative infinity to infinity. It's never negative, is it? And if you remember the average rate of change, so if I go to 2, 2, my interval from 2, so we want to know what it is from 2 to 6, right? Well, that's the ordered pair 2, 2, and 6, 2, and you should get 0. 2 minus 2 over 6 minus 2, which gives me 0 over 4, which is 0. So my rate of change is 0. Constant's going to be 0. Okay? All right. Example 4. Okay. So on this one here, my x-intercepts are here, here, and here. So my x-intercepts are negative 3, negative 1, and 4. My y-intercept, do you agree with me, is 1 right there. There's my y-intercept. It's 1. My domain, left to right. That's an open circle, so my domain would be parentheses negative 4 to 0.4, which is a point, so it's going to be a bracket. My range is floor to ceiling, so that would be negative 1. When it does this right here, that's considered a point, so it's bracket, to 3, bracket. Okay? It's increasing on this interval right here. And that x value there is what? Increasing from negative, What's x there? Negative 2 to positive 2. It's decreasing from negative 4 to negative 2 and 2 to 4. Okay? It's never constant. It's positive. This one's going to be a little more difficult. So positive here, here, and here also. So you end up, you're always going to use when you use positive values, you're going to use those x-intercepts. Okay. So it's positive from negative infinity. Whoops. It would be positive from negative 4, right? Negative 4, correct? To negative 3, not included. Correct? From here, which is an open circle, to there. Then it's from positive from negative 1 all the way over here to 4, not included. And then it's negative on this interval here, from here. Again, it's, whoops, I don't want to use that one. I'm going to use a different one. Let's use this blue one here. It's negative in here. So that interval's from negative 3 to negative 1. Okay? And then average rate of change. So the ordered pair for 1 and 4. So 1 is what? 2, and 4 is 0. So my rate of change would be y's over x's, so 0 minus 2 over 4 minus 1. So that would give me negative 2 over 3. So my rate of change would be negative 2/3. Okay? I'll pause this real quick. You're ready for the next sheet. Share notes up here with this. So, of course, a linear looks like this, correct? So it's increasing the whole thing from left to right. So it's negative infinity to infinity. It's never decreasing. It's positive from 0 to infinity. And it's negative from negative infinity to 0. The average rate of change would be 1. Because no matter what point you go, you're going to go up 2, but your y is going to be 2, 2, 3, 3, 4, 4, whatever. And when you subtract, you're going to get 1 over 1. Your quadratic looks like this. Correct? Your linear equation's this here. Your quadratic equation's this here, your parent function at least. So it's increasing from 0 to infinity. It's decreasing from, on this side, from negative infinity to 0. Negative infinity to 0. And it's positive the whole time. So that's negative infinity to infinity. It's never negative. And average rate of change, so let's use x as 1, then y will also be 1. And if x is 4, I square 4, I get y is 16. Is that right? So 16, so I'm going to take 16 minus 1 over 4 minus 1, which gives me 15 over 3. So I end up with 5 as my rate of change. Okay? Cubic is y equals x cubed. It looks like this. Okay, it's increasing from from 0 to infinity, correct? From 0 to infinity. And it's decreasing from negative infinity to 0. Okay? It's positive on this side from 0 to infinity, and it's negative from negative infinity to 0. And then if I put in 1 in the cubic, I get y is 1. And if I plug in, let's say, x equals 4, I get y is 64, because 4 cubed is 64. So then I'm going to find the rate of change is 64 minus 1 over 4 minus 1, which would be 63 over 3, which would be 21. So my rate of change would be 21. Up here it was 5, here it was 1. Okay. Absolute value is a V-shaped graph, correct? So there's your parent function. So it's increasing from 0 to infinity, correct? It's decreasing from negative infinity to 0. Okay? It's positive. The whole thing's above the x-axis, so it's negative infinity to infinity, all real numbers. It's never negative, and the rate of change, I'm going to pick some points here. When x is 1, y ends up being positive 1. When x is 4, y is 4, correct? So rate of change is 4 minus 1 over 4 minus 1, so I end up with 3 over 3, which is 1. So my rate of change for the absolute value is 1. Exponential, I'm going to use y equals 2 to the x, so it looks something like this. Okay, it's increasing the whole time from left to right. It's decreasing never. It's positive because it never goes below the x-axis the whole time. It's never negative, and the average rate of change I'm going to use for exponential when x is 1, y ends up being, so what's 2 to the first would give me 2 for y, and then when x is, let's say, I don't know, let's use 4, then y would be 2 to the fourth would be 16. So my rate of change would be 16 minus 2 over 4 minus 1, which would be 14 thirds. So there's my rate of change for the exponential, 14 over 3. Square root looks like this. Okay? Okay, it's increasing from 0 to infinity. It's neither decreasing. It's positive from 0 to infinity. It's never negative, is it? It's always above the x-axis. And let's say I put in 1, x is 1, the square root of 1 is 1. And let's say we put in x is 4, the square root of 4 is 2. So difference of y's over difference of x's, so I get 1/3. Okay, for the rate of change. Last but not least is cubic. And it looks like this. Okay? Cube root, excuse me, not cubic. So what is it's increasing from left to right the whole time. It's never decreasing. It's positive from 0 to positive infinity, and it's negative from negative infinity to 0. And then now let's find when x is, that's my input, is 1, the cubic root of 1 is 1, so y would be 1. If I put in x is 8, then y would be 2, correct? So when I put, let me show you how you get that. So I put in like this for x, I put in 1. So the cubic root of 1 is 1. So that's how I get 1 for y. For 8, the cubic root of 8 is 2. That's how I get y is 2. So now let's find 2 minus 1 rate of change over 8 minus 1. So that gives me 1/7. And there's my average rate of change for a cube root. The homework is in there for you. This is Wednesday. Watch this. I will be back Thursday and Friday. For you guys, it'd be Thursday to go over all this stuff with you, okay? Have a good day. What's left of it.